Hello, my name is Emilio Alonso Venegas Hernandez. I represent, I am representing the team Bolillo Cósmico from CETI Colomos. Our solution to the problem of cheese test is named double determination of cheese, quantification of total aldehydes and chloride ions by modified argentometric filtration and potentiometry. The objectives of our proposal is to provide a precise method to determine aldehydes in cheese and also determining the amount of chloride, So therefore we can determine the salt composition of cheese. Also is to offer an alternative, lower cost and greater ease of use. The hypothesis is utilizing a potentiometric argentometry for quantifying aldehydes and chloride ions provides a precise and exact method for application in cheese analysis with a considerable simplicity of execution and using available reagents and equipment. In our conceptual framework, we will be using argentometry, Morse method, and Colomos reagent. Argentometry is a type of precipitation filtration that involves silver 1 ion. It is typically used to determine the amount of chloride present in a sample. The solution is titrated often with a silver nitrate solution. So silver chloride can precipitate in a characteristic white color. Morse method utilizes a potassium chromide indicator that once all the chloride has reacted, silver reacts with chromate ions to give a red precipitate that can be detected in the precipitation container, in the titration container. The solution needs to be pH controlled, and it has to be near neutral because silver hydroxide forms have higher pH and lower pH. Chromic acid is formed. These two reactions can reduce the reliability of this method. So pH needs to be controlled. Colomos reagent is a chemical reagent used to distinguish between aldehydes and ketones. Consists of a solution of silver nitrate, ammonia, and sodium hydroxide. Aldehydes get oxidized to carboxylic acid, and the silver ions turn into metallic silver. The preparation consists of two principal steps. One is the formation of silver oxide in a basic media, and the next step is the solubilization of this oxide with ammonia, leading to the complex D-amino silver. The proposal is to homogenize the cheese sample by polymerizing with a solution of sodium citrate to sterilize it. Then we will adapt the Morse method, but before we do this, we need to eliminate any considerable interference that is given by carbonate ions and phosphate ions. That's why we will use sodium acetate and diamperic acetate to precipitate one of the two ions respectively. And then all the resulting precipitates are filtered. Then we can continue with the chloride determination. Then, as we mentioned, we will treat it with silver nitrate and using the Morse indicator. That way we can visualize the equivalence point. Then we will filter the resulting precipitates. So we can proceed finally with the aldehyde determination. By using Colomos reagent, we can oxidize selectively aldehydes of any kind. And we will be using a selective electrode if available, but this method works with any electrode as long as you know the potential of the paired silver. The paired silver 1 and metallic silver. Then with this electrode and the sample, we will construct an integration curve, as we can see in this image, where we plot electric potential in function of the volume of the different added. In this case, is the tolerance reagent. The samples needs to be prepared and set to a high pH, so tolerance reagent is stable in the solution. By using the curve and comparing it with the known potentials, we will be able to determine the equivalence point and calculate total aldehydes. Repeating this method with several aliquots can give us a result that is statistically significant and therefore an useful inference. Why is it a viable solution? Actual determination methods imply using HPLC, which is a type of chromatography that requires a treatment of high cost. Our method can be executed at any lab with reagents and equipments, which are quite affordable. Also, the procedure can be done by anyone with basic knowledge in analytical chemistry. Finally, electroanalytical methods are far more precise than gravimetric ones, and these provide a precise follow-up of a reaction. If there's any doubt regarding the presentation or the proposal, write to the following email. Thank you.